Supernovae are among humanity's greatest nightmares. They emit harmful radiation and destroy the balance in the biosphere on planets. More terrifyingly, new research shows that their effects on our planet could be even more devastating, literally tearing up our atmosphere. But just how devastating is this effect? And can we possibly avert it? To understand this mystery, we need to start from the very beginning by exploring the origin of supernovas. Without complicating things, a stellar explosion is an outburst that occurs when a massive star reaches the end of its life cycle. During this intense activity, some fundamental building blocks of nature like X-rays, iron, and blast waves of other fast particles are emitted from the outer layers of the star into the universe at an incredible speed, between 9,500 and 25,000 miles per second. One single supernova explosion can render an entire planet useless. For instance, one of these explosions happening in our galactic neighborhood can all but end all traces of life on our planet. Scientists and astronomers have had an idea about supernova explosions since the 17th century, but ironically, it's an interesting process that we're still learning about. According to the current estimates, scientists at the European Space Station believe that a supernova explosion occurs in a galaxy about the size of the Milky Way at least once every 50 years. Based on this, we can assume that, on average, a star explodes in our galaxy every second. However, not all of these stars explode the same way. In fact, scientific observations have shown that there are two possible outcomes for a typical supernova. The first outcome, known as a Type 1 supernova, sees the star accumulate matter from a neighboring star until a runaway nuclear reaction is triggered. Alternatively, the star could exhaust its fuel and collapse under its own gravity. The Crab Nebula, spotted by Chinese astronomers in 1054, is the most significant supernova discovered in human history. However, more recently, a star called Betelgeuse has been making headlines all across the world. It all began in 2019 when the glittering star situated in the upper right shoulder of Orion experienced a sudden darkening. This process continued as the star continued to dim across several months. Astronomers are not exactly sure what this means for Betelgeuse. Some suggest that it could have blown off its surface in a first-of-its-kind coronal mass ejection. We've never before seen a huge mass ejection from the surface of a star. We are left with something going on that we don't completely understand. Andrea Dupree, an astrophysicist, explained, "It is a totally new phenomenon that we can observe directly and resolve surface details with Hubble. We are watching stellar evolution in real time. In reality, it's not uncommon for stars to experience coronal mass ejections. It happens occasionally when some of the elements known as corona are released into the Earth's atmosphere. When this happens, it affects our satellite communication infrastructure in space, as well as some of our power grid systems on Earth. In other words, the effects on human activities can be quite devastating. But interestingly, the effects of the surface mass ejection that we witnessed with Betelgeuse are 400 billion times greater than the typical coronal mass ejection from our Sun. If it had happened anywhere near Earth, our entire civilization could possibly have been wiped out. But at its current location, which is over 600 light-years away from us, the star continues to burn fuel in its core. Consequentially, it has swollen to become supermassive, up to around 1 billion miles in diameter. However, the red giant star doesn't seem to be done yet because, according to NASA, it is bound to become a supernova anytime now. Reading the report and their choice of words, one would think that the event could happen within a few weeks or maybe years. But as you know, the cosmic scale is quite different. So most likely it's going to take a few million years before the big happening for Betelgeuse. Although it could happen this very moment too. Normally, when a red supergiant is about 10 to 40 times more massive than our Sun, becomes incredibly dim and turns super red, a supernova is bound to happen. This is according to the submission of Benjamin Davies and his colleague at Liverpool John Moores University. To clarify their position, this group of scientists repeated the process that causes the pre-mortem dimming of stars through simulation using computer models. Consequentially, they compared the results of this experiment with the results of their observations of red supergiant supernova in nearby galaxies. This led them to the conclusion that in the weeks or months that precede a supernova, a star's visible light would most likely become about 100 times dimmer. This interesting dimming and reddening occurs simply because the star is covering in a dense cocoon of hydrogen and other elements during its final months. However, stars are also believed to eject these gases from their surfaces in a series of small explosions as the star approaches the end of its life cycle. During this phase, around the final year or two of the star's life, it burns neon, then oxygen, before eventually burning silicon in its core. As each element burns out, the core of the star partially contracts before igniting the next element. In the case of Betelgeuse, when it finally explodes as scientists have predicted, it will be the second brightest object in our sky after the Sun, despite being over 600 light-years away from us. Skywatchers and ordinary humans would be able to see the explosion during the day. Additionally, this ultra-bright phenomenon will be so bright that it will cast shadows, even in the thick of the night. This incredible brightness does have its side effects, though. According to scientists, such an occurrence, among others, could cause blindness in humans. However, the light emission is believed to just be a tiny fraction of the overall energy output of the supernova process. At its peak, this intense reaction could also cause high-energy radiation in the form of X-rays and gamma rays to enter the Earth's atmosphere. High-energy radiation, as you know, can catalyze oxygen, which in turn destroys the already overstretched ozone layer. It's needless to emphasize how detrimental this would be to humans because the ozone layer, as we all know, is key to the existence of life on Earth. It helps to shield us from the intense ultraviolet radiation emitted by the sun, and without it, we would be left exposed to these dangerous elements, which could ultimately lead to the extinction of the human race. But that's not all. In fact, streams of high-energy radiation released into the atmosphere also pose a much bigger threat to humans than depleting the ozone layer. This is because when cosmic rays or subatomic particles are accelerated to nearly the speed of light and burst out of the maelstrom after a while, they carry some of the energy from the supernova process with them, meaning they could also deplete ozone layers and tear apart a planet's atmosphere or surface with some deadly high-energy radiation. And in case you're wondering, it's not a new phenomenon. We've seen it happen in the past, and the evidence remains with us even to this day. For instance, scientific analysis of the lunar regolith and deep-sea cores reveals the presence of iron-60, which is a radioactive isotope of iron produced only in supernovas. This implies that our Earth may have been hit by a supernova ejected some millions of years ago. Also, in a scientific paper published in the Archive database in October, scientists found another type of supernova with more range that poses an even greater threat to habitable planets like Earth. Expectedly, this newly discovered supernova occurs when a star is close to the end of its life cycle but is covered by a thick disk of materials. In this situation, once a typical supernova explosion occurs, a shock wave forms and collides into that disk. Consequently, the shock wave heats the disk to temperatures that, in turn, cause the disk to emit high amounts of X-ray radiation. One such explosion happening around 150 light-years away can attack the Earth's ozone layer and potentially deplete it by 50%. Following the initial burst, the attacked planet would be hounded by a wave of X-rays, which would open the heaven's gate for cosmic rays to strike as well. But thankfully, Earth is situated at a safe distance from potential X-ray supernovas in our neighborhood, meaning our ozone layer can maintain its relatively healthy condition, at least in the near future.